Let's look at the solution to the 2020 JAMB Physics examination question 1 to 10. Question 1 here says, a vector quantity can only be completely described when dash and dash are mentioned. A. Magnitude and motion. B. Magnitude and direction. C. Distance and specified displacement. D. Moment and momentum. For this question, the correct answer is B. Magnitude and direction. You want to take note that a vector quantity is simply a quantity that has magnitude, and by magnitude we mean numerical value, right? So when they say vector has a magnitude, the term magnitude simply means a numerical value or size, right? Numerical value or size. That's the meaning of magnitude, and also direction. An example of a vector is weight, right? Weight is a vector. So if I say a man weighs 15 Newton, for instance, right? The magnitude of the man's weight is 50 because that's the size or that's the numerical value. Now, what's the direction? We know that if you have a man standing here, his weight will act downwards. In essence, his magnitude is 50 or perhaps 50 Newton, and his direction is downwards, or the direction of the weight is downwards. So a vector must have both magnitude and direction. So that's why B is the correct answer. Number 2 says, what is the relationship between mechanical advantage MA, velocity ratio VR, and efficiency E with percentage? Now we know that from the concept of efficiency, we know that number 2, efficiency E is equal to the ratio of mechanical advantage all over velocity ratio expressed as a percentage. So here is the relationship. So do we have any E equal to, let's say this, E equal to MA over VR? That's option A. MA over VR times 100%. So A is the correct answer. Question 3 says, a cube of block of 6 cm side and mass 257 gram has a cavity inside it. If the density of the block is 2.75 gram per cm cube, what is the volume of the cavity? A. 3 cm, B. 5 cm, C. 122.5 cm, D. 7 cm. So how do we solve this question? Now the first thing you want to note here is that they mentioned that this is a cube. And for a cube is simply a three-dimensional shape made up of squares. That means all the sides are equal. And if they give you one side as 6 cm, we can easily find the volume of this cube, knowing that the length, the breadth, and the height they are all 6 cm because it's a cube. Okay. Now that's the first thing. Again, let's see. Do I have to convert? Looking at this, they gave you the side of the block as 6 cm. They gave you the mass as 257 gram. So do I have to convert to meters or kilogram? All you have to do is watch the value or watch the unit of the density. Density of the block is 2.75. The unit there is gram per cm cube. So you observe that both are grams, and then you have cm and cm cube. In essence, I do not have to convert. All right. Let's take down parameters we have. Number 3, we have side. So number 3, let's call it length. We have length L as equal to 6 cm. With this, we can easily find the volume of the cube. Right, so volume of the cube, volume of cube V is equal to 6 times 6 times 6. For a cube, all the sides are equal. All right. So if you punch 6 times 6 times 6, that gives you 216. So I have 216, of course, cm cube. Okay, so that one is sorted. Next up, they said, and mass. So number 2, you're giving mass M as equal to 257 gram. So 257 gram, that's the mass. Also, you're given the density of the block. So density Let me use rho as equal to, what do we have there? 2.75, 2.75 gram per cm cube. Now, all I have to do is simple. I already have the original volume of the cube as 216. Using mass and density, we can find the volume of this cube. Don't forget, they said the cube has a cavity or a hole in it. And we are asked to find the volume of this cavity. To get the volume of the cavity, all we have to do is to subtract the original, for this original volume here, we'll subtract the volume we get by combining mass and density together. We'll have a particular volume. Subtract that value from the original volume, and you have the volume of the cavity. So how do you get volume from mass and density? Recall that density rho is equal to mass over volume. And in that case, from here, if I make volume, right, the subject of the formula will have that volume is equal to mass over density. And that's equal to, the mass is 257, so 257 in grams all over, the density there is 2.75, so I have 2.75. Let's divide this. This is equal to 257 divided by 2.75. The value there's about 93.45, right? So you have this as 93.45. Volume will be in cm cube. So this is in cm cube. All right. So with this, we can say, therefore, volume of cavity, therefore, the volume of the cavity is equal to 216, which is this original volume, minus the one I got from the density and mass, 93.45. 93.45. Let's subtract this. 216 minus 93.45. That gives you 122. This is 122.55 approximately. That's 55 cm cube. Right? So that's your answer. So let's see which option we have there. 122.55. Okay, we have this one here. Right? We have this. Right? So 122.5, maybe due to that approximation. Of course, it should be a cube here. So C is the correct answer. All right, question 4. Question 4 says, what is the required heat to change the energy of a mass of ice at 8 kilogram when the water is at 0 degrees Celsius? You are asked to take the specific latent heat of ice to be equal to 336 times 10. This will be times 10 to the power 3 times 10 to the power 3 joules per kilogram. You have this. All right. So how do we have option A, option B, option C, and option D? So how do we solve this particular question? Now, question 4. Right, question 4. To solve this question here, the formula you use here is that the heat of energy, right, that's Q, is equal to mass of the substance M times the specific latent heat of a substance. All right, so Q is equal to ml. Don't forget that M is mass. So let me use a small m instead. That becomes mass M times the latent heat. The specific latent heat of a substance. Looking at the question here, you're given the mass as how many there? 8 kilogram. So you have mass as 8. So this is equal to 8. You're given the specific latent heat of ice as 336 times 10 to the power 3. That's 336 times 10 to the power 3. You have this. And you're asked to find the required heat. All right. To find this required heat, all we have to do is just multiply these two numbers. So you have to find Q. Q is equal to, I'll get my calculator and I'll punch 8 times 336 times 10 to the power 3. That's about 2688000. So you have this. I think the options are in index form. All right, so let's produce this in index form. So this will be equal to, take your point here, it becomes 2.6. This 8 here becomes plus 1, right? So 8 plus 1 here, that becomes 9, 6, 9. From here, moving 1, 2, 3, 4, 5, 6. So times 10 to the power 6. This is my index form, of course, in joules. So let's see which option is this. 2.69 times 10 to the power 6. That is option A. So option A is the correct answer. Question 5. Question 5 says the device in which one circuit controls another, especially if the current in the second circuit is large or dangerous, is known as A. Electromagnetic device, B. Magnetic relay device, C. None at all, D. Sextant. All right. So what is the correct answer to this question? Now, for this question, you want to note that they mentioned B as magnetic relay device. A magnetic relay device is a device that controls a circuit, that is one circuit, if the current in the second circuit is large or dangerous. So the answer to this question here, for this question here, the answer is B, magnetic relay device. Okay. You want to take note that a magnetic relay device is a device that controls a particular circuit or one circuit, of course, if the current in the second circuit is large or dangerous. So if the current in a particular circuit is large, very large or dangerous, we could use a magnetic relay device to control it from a different circuit. So that's your correct answer. Question number 6. Efficiency of a transformer is equal to A. Efficiency of, okay, so you have option A, option B, option C, and option D. Basically, you're being asked to give the numerical or the mathematical form of the efficiency of a transformer, basically. Now, number 6, you want to note that efficiency of a transformer of the efficiency of a transformer is equal to the power developed in secondary coil. So let's say power in secondary coil, but power developed, power in secondary coil all over power in primary coil, power in primary coil, of course, times 100%, expressed as a percentage, times 100%. All right, so efficiency of a transformer is equal to power developed in secondary coil all over power developed in primary coil expressed as a percentage. That's question 6. So let's see which option that is. Looking at the option here, the A says secondary coil over primary coil. Mechanical advantage. B says mechanical advantage over velocity ratio. C says number of turns. D says power developed in secondary coil divided by power. I think D should have been the answer, but it's not complete. So this efficiency of a transformer is equal to power developed. Yes. So it's not just, now A looks the same thing, just that D has power developed. So I'll go with D. Right. I think it's a typo error. It's not complete, but it should have been power developed in secondary coil divided by power developed in primary coil times 100%. So I think D is the correct answer. Question 7. A resulting force of 20 Newton acts on a body of mass 5 kilogram, changing its momentum by 200 kilogram meter per second. For how long does the force act on the body? A. 5 seconds, B. 15 seconds, C. 10 seconds, D. 7 seconds. So how do you answer this question? For question 7 there, let's look at the parameters we are given. They said force, a force of 20 Newton, they're given force F equal to 20 Newton. Again, they said on a body of mass 5 kilogram. So mass M is equal to 5 kilogram. What else? They said changing its momentum by, you have this 200 kilogram meter per second. So you're given momentum P as 200 kilogram meter per second. So kilogram meter per second. What else? You ask how long does the force act on the body? All right. How long does the force act on the body? How long? That's about time. So T is equal to unknown. All right. So how do we solve this question? Now, for this question here, you want to note that there is a relation between force, time, and then momentum. And the relationship is that impulse is equal to momentum. And this is true because they have the same unit. Impulse, as we know it, is force times time is equal to momentum. All right. And momentum is already given here as 200. So the momentum is already 200. The force given there is 20. Or before then, we could get time divided by force, divided by force. This cancels this. So the time T is equal to 200 all over the force. The force is 20. So time T is equal to 200 over 20 gives you 10. All right. So the value here is 10 seconds. So question 7, the answer is C there, 10 seconds. So you have this. All right. Next up, question 8. Question 8 says if an object, I think this should be whose, if an object whose mass is 3 kilogram moves in a circular path of radius 0.7 meters, records a speed at 2 meter per second, what is the result of the angular velocity? A, 4 rad per second, B, 1 rad per second, C, 3 rad per second, D, 4 rad per second. In this question, you're given mass, you're also given radius, you're given speed. Now, if you're already given speed at 2 meter per second, you're asked to find the result of the angular velocity. Now, how do you correlate angular velocity with speed? This speed you're given here is your normal speed or normal velocity. And you want to note that for question number 8, you want to note that the linear velocity v is equal to the angular velocity times radius. So you have this, right? Angular velocity times radius. So what's your v? Your v, which is the normal speed, is given here as 2. So you have that 2 is equal to angular velocity and then radius. The radius is 0.7. So I have this as 0.7. That means from here, we can get angular velocity, divide here by 0.7, divide here by 0.7. This cancels this. So angular velocity is equal to 2 divided by 0.7. And if you do that, this is equal to about 2.86. This is measured in rad per second. So 2.86 rad per second. Let's see which option that is. We have 3 here. This is approximately, which is approximately 3 radians per second. So the correct option here would be C, 3 rad per second, 3 rad per second. That's your answer. Question number 9. Question 9 says if an object is placed at a height of, I think this should be 10, right? A height of 10 above the ground at a stationary point. It possesses what types of energy? A, mechanical energy. It possesses what type of energy? A, mechanical energy. B, stationary energy. C, potential energy. D, vibrational energy. Now, for this question, you want to know that when a body is at a particular height, all right? Let's say I have this as my, okay, let me do this better. Let's say I have a ground surface here. All right, this is my ground surface. And you have a particular height here, from here to here like this. This is my height. I'm going to call from here to here. I'll call it H. All right, this is H. This is H. All right. And we say, let's say we have a body here. Let's say a round body. Have a round body on the height here, like this. All right, at a particular height. Now, the energy possessed by this body here, due to the height from point A, which is the top of the height there, to B, is given by mass, the mass of the body, times gravity, trying to pull the body down, times the height there. And this is equal to potential energy. So note that potential energy is the energy possessed by a body at rest or due to a body's position, that's a body's height. So the correct answer there is potential energy. So for this question here, the correct answer is C, potential energy. Finally, question 10. Question 10 says Boyle's law may be written as, so you have this. So what you have option A, option B, option C, and option D. You're asked to state or write Boyle's law in mathematical form. Now, for Boyle's law, question 10, for Boyle's law, note that Boyle's law states that the volume of a given mass of gas, let's say V, at a constant temperature is inversely proportional. That's 1 all over to its pressure. So this is Boyle's law, right? In mathematical form. The volume of a given mass of gas is inversely proportional to its pressure, of course, at constant temperature. And if I'm to work on this, this will be equal to take off this proportionality sign, I'll put an equal to and introduce a constant, then dot 1 over P. This will give you, or this will translate to V, that's V, being equal to K times 1 gives you K all over P. This becomes all over 1. If I multiply this, K times 1, you have that K is equal to P times V gives you PV. All right. So from here, we can now say P1 V1 is equal to P2 V2. Basically, this is Boyle's law. All right. So let's see which option that is. That is option A. P1 V1 is equal to P2 V2. That's option A. All right, guys. So that's about it for this video. And as usual, I'll give you one question for you to try. And that will be question number 11. Question 11 here says, the two liquids which are often used in thermometers on experiment basis is known as A, mercury only, B, alcohol and water, C, mercury and alcohol, D, alcohol only. So what are the two liquids that are often used in a thermometer, right, for experiment basis? Is it option A, option B, option C, or option D? Leave the correct answer in the comment section and I will tell you if you're correct or not. Okay? Okay, guys. So please take note that we have a JAMB WhatsApp group for 2026 JAMB Bites. All right. So if you're writing JAMB for 2026, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.journalemmanuel.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right. For the comment, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I will tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.